Good afternoon. My name is Denis Gracanin, and this presentation is based on the ongoing PhD research of Shaymaa, Khater, my PhD student, and my colleague Hicham, Elmongui. So what we're trying to do here is to explain our development of a personalized dynamic recommender system for tweets, and in order to do so, we'll first provide some brief introduction motivation for the problem, then continue to describe the approach or the system that is currently being developed, and then talk about some of the results, and then conclude and talk a little bit more about possible future work. So now I know that I'm preaching to a choir, but information, social networks are growing tremendously. Just most recent information is that there are 500 million tweets sent every day. I think just a couple of years ago that number was something like 58 million, so we have like a tenfold increase. And then the problem is that social network and social media produces an overload, and that overload goes through, just the sheer amount of information to amount of time required, interactions, and so on. So, which means that if you are having a rich social network life, so to speak, that may negatively affect your traditional social life. So therefore, there is a need somehow to address that problem and explore it. And certainly, this is a very interdisciplinary problem going from social and technical issues. So what we are trying to do here is to look at that from one small segment, and that is what can we do in order to provide some more individualized and more, personal recommender system. So then from that point of view, our problem is how do we reduce social media overload, and then again the goal is to develop a system that will take that input stream of tweets from the user timeline, reduce it, or at least reorder it so that most interesting, hopefully most interesting and most relevant tweets are presented to the user first. So in order to do so, we have to have a system, or if you wish, a glorified tool. So the basic architecture of such a system is presented here. So there are two steps. First, topic modeling using some well-known techniques such as LDA, and then once we have those topics classified and have some probability values assigned, then we can look at various features from personalized level of interest, from and other features to classify the tweets and provide a personalized dynamic recommendation. So in the first step, which is topic modeling, how do we put things together? Again, we look with the same hashtag, look at the all the tweets that are replies to originating tweets, so to speak, same URL, and therefore I use those measures somehow to group those similar tweets together. So that means that at the end we are going to extract those topics and have them there. Obviously, the number of topics is not uniquely determined. We can change and vary the number of topics based on how granular we want to be with our tweets. So once we have that, then we would like to calculate for a given tweet what is the level of interest that user given the topic. So therefore, given the input tweet goes to the tweet topic classifiers and give us that distribution. In order to do so, again, we are using some basic path to add user interest, and based on user activities, going over a history of past 7 days. And more details about that you can find in the paper. But just to illustrate, so in this diagram here, you actually have 3 topics, and some of the topics gradually decline over time. Some topics seems to be more periodic, or some topics grow and become more and more interesting to users. So obviously we have some one-time events or topic, or some periodic events, let's say football game, or some topics that occur once or twice a year, let's say holiday season or something like that. And then through that we can again compare and contrast those features. Features based on the publisher, for example, tweet-based features or location features, location of the user we can actually get. I guess arguably one of the main challenge, or the main challenge in actually to do this kind of research, is to get a good data set. So because default, using Twitter REST API or similar API, you really don't get all the data that you need. Why? Because privacy issues, users' timeline is something that that might be difficult to gather. So what we did, we used results from a project Virtual Town Square, also from our colleagues at the Department of Computer Science at Virginia Tech, and we used it to seed the data with 100 active users, and then we follow up, what tweets those users were interested in, and so on. So at the end, we constructed the database or dataset consisting of 5 million tweets and 20,000 users. And so for that time period, April 2013 to June 2013, in 3 months, we actually had a fairly decent amount of data that allow us to construct approximate, I emphasize this, approximate user timeline, because again, due to various reasons, primarily privacy, that's not something that we can get from the user or about the users. So how do we approach that? Well, we look at the possible situation and what indicates that certain tweet is on user timeline, or basically retweeting, posting, and what are the users' favorites. So for those various categories, we have established approximate time interval within which the tweet is of interest, and use it to construct the timeline in more specific time. So once we had that basic pre-processing phase and then have constructed the timeline, so we then do what we did next is actually try to do some pooling of that data. In other words, grouping those tweets together and creating various number of pools. So this gives you some idea how we can actually, through various filtering or and various how should I put it, parameters, we can reduce pool size. Well, sorry, try to reduce number of pools and group aggregate those tweets. So at the end, we actually went through topic extraction, and this is some example of topics that are there, and this very high level, and what are the corresponding words for the given topic. These are the words that then we can later use in classifying those tweets. The measure that we use to evaluate that, obviously the traditional measure precision and recall. In other words, how accurate is that true positive or detection of our system. What we have also added, the dynamic level of interest. In other words, that classification process is not only based on overall state, but also on what is the past user history and calculated level of interest based on the individual topics. We use 3 types of classifiers just to see, to explore the classifier space in terms of calculation time, precision, and overall complexity of implementation. So here are some illustrations how we were actually able to improve both precision and recall when adding dynamic level of interest. I think to the for all 3 classifiers, we've seen some improvement. Different classifiers behave differently based on some other criteria we'll discuss in subsequent slides. So in terms of user activity, so it's kind of tricky, because if user is not very active, you don't have really that much data, and some of those classifiers may not work as well as this example here with SVM, where the for users that are not very active, we actually have decrease in terms of precision. But for very active users, for which arguably those recommender systems are most useful because they have most of that social media overload, the classifiers are actually fairly successful in terms of improving the and predicting what is going to happen. Some other set of features, or some other features that are important during the classifying process are listed here. And as we can see, that in addition to what are the followers and what are the number and so on, level of interest is one of the most important factors that actually are considered in the classification process. So finally, if we want to summarize that overall, looking through all those classifiers, we have seen that we have actually improved on average precision and recall. Precision a little bit less of 1%, but recall over almost actually over 6%. And not only that, we also did some additional study in terms of number of topics, because what is the issue? In terms of perplexity, in other words, how good our model is, obviously the larger number of topics, well, at least that's what our study showed, that the larger number of topics will actually lead to better perplexity of the lower perplexity values. So we actually had perplexity best for 60 different topics. However, as we vary the number of topics, remember I said that we can number of topics is not uniquely determined. We can vary it based on granularity that we desire. We found that sweet spot around 35 topics in that data set that is that provides the best improvement in terms of recall improvement, but also provides satisfactory level of perplexity. Why? Because perplexity after a certain number of topics drops off fairly slowly. So for all practical purposes, this is more or less the same. In terms of practical use, remember, this is something that's done on a daily basis. It is not something that's done in real time. And the most complex case, in other words, when using SVM classifier, it took maybe a couple of hours. And also, truth be told, we didn't really focus on speed or efficient implementation. We focus on developing systems which will allow us to explore these characteristics. And finally, in conclusion, what this work presents, again, an ongoing research that how to develop personalized dynamic recommender systems. Result shows that, again, not on average, but in best case scenario, we can have up to 36 and 80% improvements in terms of precision and recall, respectively. It works better for the user with higher activity level, which is precisely the user that needs such a recommender system. And finally, that we can provide some additional improvement, and if we carefully select the number of topics, overall, let's say, possible number of topics that we can get given the user history. So with that, I finished the paper. I hope I was fast enough. Say again, please.
What was the size of your feature matrix? Like you use SVM, right?
Yeah.
So here you have to use like some sort of features for evaluation.
Okay, let's just go back. So these are some of the indication of the features that we have had, and in addition to that, for the level of interest is actually we also have 0 1. Yeah. So. The size, not the size. So if you look at that, we thought actually you got me there because total number size are anywhere between 15 and 17 based on the classifiers being used.
Only 15 and 17?
Yeah, I mean, okay, perhaps. Here is the thing. If you're looking, there are two steps. One is the topic modeling, and one is the classifier of the actual tweets. So it depends. I am assuming that you are asking for the classifying the tweets.
Yes.
So these are the basic, there's a number of tweets that we have. So in addition to, of course, the topics that we're saying, topics are separate, because what you have for each topic, you have a vector that gives you user activity level, and that's on the side. On top of that, we have additional 15 to 17 features that are being used, such as, let's say, publisher-based, explicit features, and so on.
I have a question. You came to the conclusion that 35 was a sweet spot.
For this particular data set, too, yes.
Now, do you think that might be repeatable in other data sets? Do you think that's a potentially empirical figure that people might start working towards, a bit like the Dunbar number?
I would say yes, because again, with perplexity, usually, I mean, it's more or less when you have larger number of spots, it goes down. However, you have then opposing trends, which basically means the more, how should I put it, the more topics you have, it's more difficult to actually predict that. So kind of in the middle, you have that sweet spot. So I guess that's where at least my naive interpretation of that. It certainly requires far more work to be able to say something with more certainty, I should say.
That certainly is an interesting area.
Yeah,
of research.
yes. That's actually the last topic. Yeah, because that's where we find out, okay, what happens if you vary the number of topics, and we did the experiment, and this is certainly something that we'll continue to explore.
Thank you very much.
You're welcome.